I'm going to talk about software intelligence, and as the slides come up here, the notion of being able to leverage, as part of a modernization planning and execution perspective, the contents of the systems that you actually have in-house that you're running in your organizations today. In yesterday's presentation with IBM, we talked about how using software intelligence, this notion of deterministic data derived from applications, structures, and source code can be used as an input into agentic AI to accelerate and execute modernization. And we also discussed how this deterministic data can be used to vet and evaluate what AI generates as code that will be put into applications. The theme of this event around IT modernization and AI, there's this perception that IT modernization is a one-time event, but the reality is that you're always modernizing from a perspective of applications and systems within a large organization. So what we want to talk about today, and I'll provide some use cases to build a little bit on how this deterministic data can be used as the slides catch up with me. We'll go through some details how this deterministic data can be used in specific use cases that are happening every single day in large organizations with systems IT. So I'll pause for a moment just to let the slides. When we talked yesterday with Team IBM, we talked about the fact that language models do not get the full picture. I think it's advancing on its own. So the language models, AI does not get you the full picture when it analyzes, when you're putting code into language models. And the reason for that is that AI is probabilistic in nature. It's being trained on repositories that have fragments and files of code. What language models need is data that they can then use to process, to start working in terms of looking at business flows and turning the architecture of systems that are complex. It's all advancing without me. Okay. The use cases that we can talk about for leveraging language models are the whole notion here is to accelerate the ability for developers to be able to use this data and architects to make changes. The reality is that systems are very, very large, composed of millions of lines of code in many cases, and many different languages that make those systems up. So when you start thinking in terms of doing an impact analysis, for instance, on a system like this, a developer does not have a view of the full stack of the application to do that impact analysis. With deterministic software intelligence, you have the ability to have data that will provide an end-to-end view of that impact analysis so that you can then plan and execute the change on that system and actually allocate the amount of testing that you would need to be able to efficiently test that system. Next slide, if we can advance it manually. You saw earlier this notion in a previous presentation around the healthcare modernization, a notion of actually tracing process. Well, there's also a lot of process that you can demystify or understand by analyzing the full stack of the source code of a system. By understanding a call path of flow and be able to use AI to document that in plain English for an architect, a developer, or a business person in an organization to then be understanding of the business transformation that has to occur from that requires the ability to understand the full system. So in this case, the graphic on the right is a cast extract from a system that looks from tables all the way up to the user presentation to a login screen that's able to show that traceability, but then using the AI assistant that can use this information, you're then able to explain that workflow in plain English. So as you're continuing to modernize IT systems, you'll be able to communicate with the owners of these different systems in language they understand, while as an architect, you know from a code level, from a system level, the work that needs to be done. Next slide. Testing is a very costly process in app modernization because every single change needs to be tested through every pathway. As you evolve systems, you want to be able to scope testing, and creating test scripts is actually, and monitoring and maintaining test scripts is becoming a bigger and bigger part of a company's repository of code. So being able to understand exactly the dependencies across everything that's touched in a change and then being able to use AI to generate those test scripts, you can generate them, use them once for that change, execute the test, and move on. AI gives you the ability to sort of create these test scripts dynamically across the system. Next slide. A very common notion of transformation is taking legacy code and transforming it into another language. To do that effectively, you need deterministic data to understand the exact call paths and logic flows within a specific language. Then AI is very good at taking that specific context and then transforming it. So we're seeing a lot of agentic AI moving COBOL to Java, COBOL to .NET, legacy C to modern C++, object-oriented architectures, et cetera. The notion of getting that understanding for every single process then lets you integrate it into the application and then automate that workflow afterwards. Next slide. Mainframes. I think there was a presentation yesterday that talked about mainframes managing 80% of the global GDP transactions or some crazy number like that. And yet, mainframes are in continuous need of modernization. We're seeing the knowledge about mainframe systems. We're working with some folks at state-level governments that send buses to assisted living facilities to drive the mainframe programmers back into the development world so they can explain what these systems do so folks can transform them. This is an exact use case for AI, right? To be able to take that information and understand exactly the call flows within these programs, use that business rule extraction model that we just described, and then be able to safely understand how you can transform that code into something more modern that has a common knowledge base to transform. Next slide. Microservices, refactoring, very common use case. We don't need to dig into these. These slides will be available for you. Next slide. Framework replacements, very common gotcha in modernization, that there are a lot of proprietary frameworks and systems that have been incorporated over the years. The ability to have data and understand exactly where these dependencies are for these frameworks within a system. Next slide. Very common notion to move to cloud, legacy.NET, .NET Core. It sounds like these are modern languages already, right? They're not mainframe, but you still have to modernize the .NET to .NET Core, Java to modern Java, to be able to run these in cloud and take advantage of native cloud services. Understanding clearly the dependencies, that deterministic data to feed the modernization to agents, right, for those languages in context of a system is very important. Next slide. Trust but verify. So you've made all these modernization changes, and you're going to continue to do them for the next decade and next decade after that. There are established software standards that academia, government, industry have put together. I'm on a working group for this standard as well around software integrity. The standard's available at the ISO.org link that you see here in the slide, and is available. CAST fully automates the scans for these across entire systems, this entire stack that you see in the middle, so that you can then validate the AI transform code that's being delivered and deployed within your organization. Next slide. Coverage is essential. Modern systems are written in dozens of languages. AI today is very good at taking one language and moving that language forward. It's very difficult to understand something that's composed of 9, 10 of these different logos and move them as one essential piece of software forward. So CAST has the coverage for that. And lastly, I think, next slide. The ability to extract this information through MCP server, table stakes. Again, we can answer questions around that. Next slide. We lost a little bit of time here in the beginning, so I want to move forward. Solutions for portfolios and solutions for deep dive in applications. Any academia in the room that has labs that are doing research on application modernization, application refactoring, AI modernization, comfortable making both of these solutions available to you to support your academic research. We've got a great body of knowledge within CAST from billions of lines of code that have been analyzed that can help influence that research as well. That's it. Thanks.
That's tremendous and so relevant looking backwards, but also looking forwards with trying to understand what AI-generated code is doing. So thank you very much.
Sure, my pleasure.
Thank you for partnering.